Hey guys, welcome back to chapter 17. We're going to continue our discussion on average reaction rates, and we're going to put some numbers to this. So, first thing to remember is the average reaction rate is the rate at which a reaction proceeds over a period of time. So just like if we were monitoring our speed, it would be miles per hour. So how far do we travel over that hour of time? If we're monitoring, weight loss, weight gain, how much did our weight change over a year, 2 years, 6 months, whatever it may be. When we talk about reaction rates, the time period can change. It could be years, it could be days, it could be seconds. So that time period is defined by whatever reaction we're dealing with. In the last video, we learned how to write an equation for the average rate. So go ahead and see if you can write the equation for the average rate for hydrogen. So hydrogen's the molecule we're going to focus on. So see if you can write that. So for the average rate equals, okay, so we're going to have the change in time on the bottom. We're going to have change in concentration of hydrogen on the top. One more piece is that this is a reactant, so it's going to go down. And then there's no coefficient, or the coefficient is 1, so we don't have to consider that. Okay. If I were to expand this idea, so what does change mean? Well, the change in anything, but we'll talk about time, the change in anything is always final minus initial. Okay. So if we're talking about the change in time, what was the time final? 2 years, 3 years. What was the initial time? Typically it's 0 for time. Okay. If we're talking about the change in concentration for hydrogen, it's what was the concentration at some final time, what was the concentration at some initial or start time, and then we subtract those two. So change is always final minus initial. So how we symbolically represent this would be the following. So I'm putting that negative sign there because I'm just transferring it. And we would look at the change in hydrogen at some final time minus the concentration of hydrogen at some initial time. Some textbooks use 1 and 2, whatever works for you. We're going to do the same thing for time on the bottom. So we're going to look at the time at some final time, and we're going to look at time wherever we started, so initial. So this is how we would calculate the rate. So if we're given some experimental data, we can plug in the values for concentration, we can plug in the values for time, and that would give us the rate. So that's exactly what we're going to do. So we want to calculate the average rate of the reaction between the time interval of 20 and 30 seconds. Okay. So we're living in this area of the table. Okay. So what this table is as our time clicks by, so it looks like every 10 seconds they took a measurement. Over here, the measurement that they took was the concentration of hydrogen. So at time equals 0, we started with 1 molar hydrogen. After 10 seconds went by, it went down, 20, 30, 40, so on and so forth. So they just monitored the concentration of hydrogen every 10 seconds. Well, we want to know what was the average rate during the 20 to 30 seconds. What was the rate during that 20 and 30 seconds? Okay. So just as a reminder, our our equation is rate equals negative, because it's a reactant, so it's going down, change in concentration for hydrogen divided by change in time. Okay, so I'm just going to transfer that negative over. So our concentration of hydrogen at some final time. So the final time was 30 seconds. Concentration of hydrogen was 0.549. So that's going to go on the top. Minus the initial concentration. So when we started this time interval, the concentration of hydrogen was 0.670. On the bottom, we're going to do the same thing. So time final. So the final time was 30 seconds. Minus time initial. So our interval started at 20 seconds. And that's our equation. Now we're just going to plug those numbers into our calculator and chug our way through them. So on the top, I've got 0.549 minus 0.670. So that gives me a negative 0.121 molar. And then on the bottom, I've got 30 minus 20. So that's going to give me 10 seconds. Here's where we see the negatives, the purpose of the negatives. So the negatives here kind of cancel each other out, or they drop out. Rate cannot be a negative number. That doesn't make sense. So the rate, your speed can't be a negative speed, right? You're not going backwards. So rate can't be a negative number. So it's important that we have those negatives there so they cancel each other out. I'm going to divide these two numbers. So equals, we're dividing. So we're going to take 0.121 divided by 10, and we get our rate equals 0.0121. Now the units on rate. So for the past couple of chapters, we haven't really talked a lot about units, but units in this chapter are going to be incredibly important. So the units here, we're just going to transfer what we put into our equation. So the units for rate are molarity per second for this particular example. So that's your answer. Calculate the average rate of the reaction. The rate equals 0.0121 molarity per second. I hope you guys found this helpful.